Okay, so back of the worksheet. So problem 5 here. I want you to take a look at this problem and take time and try to figure out how will you start this. Okay, so take a couple minutes, read the problem. There's a lot of information here. What will be your starting point? Because as I mentioned before, it's very common for a student to, it's a difficult, okay, concept, just a difficult spot. Like we're trying to figure out where to start because there's so much information, it might be stressful, okay? So take your time, read, and try to figure out how will you start. So here, okay, we see that in Illinois Smith, the explorer, find a solid gold statue. So the first sentence, we don't really care. Okay, it's there, but who cares? He measures its volume. So he measures the volume of the statue by determining the amount of water it will displace and find that the volume of water displaced is 276.3 milliliter of water. So actually, if you read carefully, this is the volume of the statue. So I have the information on the volume of the statue. Okay? So we're going to write it down. The volume of the statue is 276.3 milliliter. Then what do we have? How much? So we're looking for how much. So that's the question. So already know what's desired. We might not know where to start, but we're looking for money. Okay, so we want to know how much. Is the gold in the statue worth, if the current price of gold is $972.40 per ounces. Okay, so you see we have the per again, very similar to what we did with the density. So let's try to understand what this means that I have that. It means that for every ounces of gold, I will get quite a good amount of money, $972.40. $972.40. Then I'm given the physical property of gold as the density. The density of gold is given to me here in gram per cubic centimeter. So remember, it's per again. So what does that mean? That for every cubic centimeter of gold, okay, I have 19.32 grams. And then the idea is to come up with a plan, okay? So I know that I can use the price of gold as a conversion factor because I have an equality. I can use the density as a conversion factor because again I have an equality. So I'm left with the volume of the statue as a starting point. So that's going to be where I'm going to start. Okay, if you recall what we did on Monday, again, milliliters, 1 milliliter is the same as a cubic centimeter, same as 1 cc. Okay, this you have to know. Therefore I know how to go from milliliter to cubic centimeter. I can simply, if I want to do cross milliliter and replace by cubic centimeter. Why did I do that? Because I want you to notice that I have here now 2 units that are the same. So I will be it's going to be easy for me to convert the volume of the statue to grams. Okay, volume of the statue, which is made of gold, to gram of gold. That's the reason why I can use the density of gold. So I'm seeing my path here. So let's try to work this out with the grid system. Okay, so let's have our line. And then let's have our conversion here. I don't know how many I need yet, so I'm just going to add, I don't know, 4 lines, and let's see if it's enough. So we start with the volume of our statue. We already crossed the milliliter and replaced by the cubic centimeter. Again, because we have to know that those are the same unit. This is how the milliliter was defined, as being the same as a cubic centimeter, the size of a dice, okay? We can use now, here, we're going to use the density to cancel our cubic centimeter and convert to gram. So now our cubic centimeter cancel. We're working our way. What we know is we want dollar, okay? So now that we have gram, we're kind of stuck because I don't see grams anywhere. What if I were to go to the end now? Okay, so I want dollar. Where do I see dollar? I see dollar here. So why not using here, okay, the price of gold to be able to get the dollar that I want. So I know that I have a relationship between dollar and ounces. So I'm left here in the middle, okay, with, do I know how to cancel grams and convert into ounces? Because if I do this now, my gram would cancel, my ounces would cancel, and I end up with what I wanted, dollar. Okay? So here is what I think is a good plan. I converted directly. I converted my milliliter to cubic centimeter immediately because I know they're the same. Then I used my density to convert cubic centimeter to grams. Then I converted grams to ounces. I always go back and I'm going to check on my useful information if I have that information. And actually, luckily, you can check. And on the useful information, the relationship between ounces and gram is given to you as being that 1 ounce is 28.35 gram. So we have this information. And then it's going to be easy for us to convert the ounces to dollars because we have the price of gold, the current price of gold. And our unit canceled properly. Now I can start doing the fill in the blank. So the 1 goes here because it's 19.32 grams of gold for every cubic centimeter. That's what the density tells us. Based on the information on the useful information sheet, every ounces is 28.35 grams. And the current price of gold tells us that we're going to get $972.40 every ounces. So now that we have our plan, fill in the blank, we can plug this information into our calculator. So what will be the calculated value? You plug everything in. My calculated value in dollar would be 1.8300568 times 10 to the 5. If I use standard notation, it would be 183,005.68, which is a pretty good amount, right? So we have to work our sig figs out now. So let's take a look. I didn't use that color. Okay. The volume is measured. So we have here 4 sig figs. The 2, the 7, and the 6, and the 3 are sig figs. The density as well is measured. We have 4 sig figs as well right there. The useful information, we're going between US and for the grams metric. So we have sig figs involved as well. Here are our 4 sig figs right there. Dollar, truly, the current price, as we know, is something that is not exact. So we have here 5 sig figs. So let's check. 4 sig figs here, 4 sig figs here, 4 sig figs here, and 5 sig figs here. We're doing multiplication and division, so we're going to go with the least amount. So our answer should be given to 4 sig figs. So let's check. 1, 2, 3, and 4. So I need to keep 4 sig figs. Because I need to keep a 0 and drop a 0 with keeping the size of the number, it's easier for me to go with scientific notation. So I'm going to use scientific notation, and I will report my answer to 4 sig figs as 1.830 times 10 to the 5 dollar. Again, the reason why I use scientific notation is because I want this 0 to count. But if I were to use in standard will look like this. It's very hard for me to write standard and to say that this 0 here, okay, that I point to you is significant, but these 2 are not. So how do I do that? Okay, because I can do it, my option is this time to use scientific notation because it's clear here that this answer as 4 sig figs. In problem 6, now we're going to be doing temperature conversion. So you're given the average temp in Paris, 7.0 degrees Celsius. So we have here 2 sig figs given in the temperature measurement. Since the 0 is after the decimal point and we have a decimal point, we want to convert this temperature to degree Fahrenheit and to Kelvin, okay? So you don't have to learn the formulas. The formulas will always be given to you. I want you to know how to apply them. So in order to go from Celsius to Fahrenheit first, degree Celsius to degree Fahrenheit, we're going to use the following formula. The degree Fahrenheit is equal to 9/5 times the degree Celsius plus 32. What I really want you to remember in that equation here is here we have a fraction, so the fraction is exact, and the 32 is exact as well, okay? So the fraction is exact and the 32 is exact. So now we're going to plug in our value in there. Okay? So we have now Fahrenheit is equal to 9/5, 7.0 Celsius plus 32. It's a combination of multiplication and addition here. Because we have the combination of both, okay, we have to work the problem stepwise in order to have correct sig figs at the end. So we're going to first perform the multiplication here. Okay, so let's take a look at this here. It's an exact number, the 9/5 times the 2 sig figs for 7. When I plug this into my calculator, I get 12.6. I'm not rounding here, okay? The reason why I don't want to round is because I'm not done yet. But I know that I will need only to keep these 2 sig figs. My next step is an addition. I'm adding step 2, 32, okay? So what do I follow? The rule I follow for addition is decimal places. Even though I wrote 12.6, only the 12 is significant, okay? So I'm going to consider in my addition that here my number has no decimal place. No decimal place because this 6 here is non-significant, okay? So I'm adding no decimal place plus 32. The calculator answer is 44.6 degree Fahrenheit. But to no decimal places, okay, again, because there's no decimal place here and because that number is exact, so it has an infinite of number on decimal places, my answer will be given to no decimal place. So I'm going to give my answer to no decimal place as, dropping a 6, rounding up, 45 degree Fahrenheit. The next, they're asking us to convert to Kelvin. So how do I convert to Kelvin? To convert Celsius to Kelvin, I'm going to follow the following relationship. Kelvin is equal to Celsius plus 273.15. Again, I want you to remember that this 273.15 is an exact number. Therefore, because you're doing an addition, you follow the number of decimal places. And since 273.15 is exact, your answer in Kelvin will always have the same number of decimal places as your temperature in Celsius. Again, these two here will always have the same number of decimal place. Therefore, let's do it. Our temperature in Kelvin will be 7.0 Celsius plus 273.15. The calculator gives me 280.15 Kelvin. This number has 1 decimal place, so my answer will have 1 decimal place. Again, this number has 1 decimal place, so my answer will have 1 decimal place. I'm dropping a 5, so I'm going to be rounding up, and my answer in Kelvin will be 280.2 Kelvin. I hope this helped, and if you have any question, please feel free to let me know.